In this video, I'd like to give a brief introduction to alcohol nomenclature. After watching the video, you should be able to classify alcohols as methyl, primary, secondary, or tertiary. You should be able to draw representative alcohol, phenol, and enol molecules, and you should be able to provide IUPAC accepted names for alcohols. Methyl alcohols are very easy to identify because there's only one, methanol. Primary alcohols have the OH attached to a primary carbon. Secondary alcohols have the OH attached to a secondary carbon, such as this one. And tertiary alcohols have the OH attached to a carbon that is tertiary. For alcohols, we're always going to have an sp3 hybridized carbon bonded to an OH. Phenols have a phenyl ring or an aromatic ring attached to the OH. This is the compound phenol, and the class of compounds have this as a partial structure. And then another ol that we will see are enols. In other words, if we have an ene, an alkene, and an ol, an alcohol, bonded to the same carbon, then we will have an enol. We will see those in chapters to come. Now, I have not shown satisfied octets for the carbons, but I'm just showing the basic essentials of what an enol is. So let's take a look at some alcohol nomenclature. I'll start with something that is very simple, and we would number this carbon chain from the highest priority functional group. So carbon 1 is going to be the one that is attached to the OH. I'm numbering the longest continuous carbon chain. There's only one carbon chain with no branching, so this is really simple. We're going to replace the E of the alkane name with an OL. So this molecule could be named as 1-propanol. The 1 tells you where the OH is attached on the carbon chain. Another way to name this is propan-1-ol. And that's a new, more modern way of naming that. Please be careful when you're writing out the names of alcohols to make sure that you're writing OL, not AL. AL indicates an aldehyde suffix, and O's and A's tend to look a whole lot alike if your handwriting is a little rushed or sloppy. Let's look at a case that's a little more complicated. I'm going to find the longest continuous carbon chain and number it so that the highest priority functional group, the OH, gets the lowest possible number. The longest chain is a 5-carbon chain, and if I number it right to left, it gives the OH a carbon number 2. So when I look at this, I know that part of the name is going to be pent for that 5-carbon chain. I know that 2-ol is going to be a portion of the name, and I know that 3-methyl would be a portion of the name. Putting that all together, by the old way of naming things, it would be 3-methyl 2-pentanol. And by the new way of naming things, it would be 3-methyl pentan 2-ol. Please notice that there is a hyphen between numbers and letters, and that there are no spaces in these names. Here's another one to consider. This is going to be named as a cyclohexanol, and we're going to number it so that the OH, the highest priority functional group, is on the lowest position in the cyclohexane, which would be position 1. If I number clockwise, I would have substituents at carbons 2 and 3, whereas if I numbered counterclockwise, I'd have a substituent at carbon 2, and then it would be a much higher number for the second substituent. So when I look at portions of the name, I'm going to have cyclohex, and I'm going to have a 1-ol, which is actually understood in a cyclohexane. I'm going to have dimethyls, and those are on carbons 2 and 6. So it's 2, 6 hyphen dimethyl. So there's commas between the numbers. And I'm going to have 3-ethyl as a portion of the name. With this molecule, there's nowhere else that the OH can be. It has to be on carbon 1, so you can leave the 1 off of the all portion of the name. I'm going to alphabetize the substituents. Ethyl comes before methyl in alphabetical order, so this is going to be 3-ethyl, 2,6-dimethyl, cyclohexanol. Again, hyphens between numbers and letters, commas between numbers, and no spaces. So in this video, we've defined various OH containing functional groups, the alcohols, the phenols, and the enols, and we've seen a brief introduction to alcohol nomenclature.